Okay, so what we want to do is replace everything that's not sine or cosine with something that has a sine or cosine identity. So we can replace secant with 1 over the cosine. That is the secant's called a reciprocal identity. So the secant is the same as 1 over the cosine. Okay, so we replace secant with 1 over cosine, and then I still have this cosine there in my problem. So in essence, I have a fraction times a number, and when you do fractions times the numbers, we always multiply top times top and bottom times bottom. So cosine over cosine is what you get when we multiply these things together. And hopefully, as you all know, anything divided by itself is 1. Okay? So in other words, the secant times the cosine is a crazy way to write the number 1. Okay, there are lots of ways to write 1. Using trig is some of the crazier ways. So in addition over here, I have another one, cotangent squared minus secant squared. Okay, so what we're going to do is write them in terms of sine and cosine. Now the cotangent is a ratio of the cosine, so since it's cotangent squared, that means cosine squared over sine squared. Because cotangent is the cosine over the sine, which means cotangent squared is cosine over sine squared. Okay, both of them. And then this one, the cosecant, hopefully you know the cosecant is 1 over the sine. Oh, these all have x's on them, by the way. I always leave them off. So I replace cosecant with 1 over sine. Okay, so the number one strategy in doing trig identities is write everything with sine and cosine. Okay, if that doesn't work, then there are other strategies, but that's the first one to try. Okay, so at its basic level right now, I have a fraction minus another fraction. And if I were to do this difference of two fractions, I need to have the same denominators. And sure enough, I have the same denominators, which means I can do my subtraction in the numerator. So I have cosine squared minus 1, that's the numerator, over a single denominator of sine squared. Okay, so I'm just doing some addition, or rather subtraction of fractions, but these fractions happen to have trig words in them. Okay, so the next step I'm going to do is I notice this cosine squared minus 1. This is also a trig identity. Okay, it's a Pythagorean identity. Cosine squared minus 1. Well, maybe it's not. No, it's not. Is it? Cosine squared minus 1 over sine squared is not the same as sine squared. So, you know what? That might be all that we can do, which seems like it's not a very good thing, but that's all.
Yeah, that's
well, upon further review, there are other things we can do. So let's see. So we know that sine squared plus cosine squared equals 1. True. Okay, so if I brought, what did I say, got to bring the 1 over to this side. Sine squared plus cosine squared minus 1, therefore equals 0. Okay, so this looks very promising here, right? This is what I have over there. Now the question is, what does that equal? So if I brought my sine over there, cosine minus 1 equals negative sine squared. Ooh, that's a random manipulation of this Pythagorean identity that you don't often use, so sorry, my bad. Instead of cosine squared minus 1, I'm going to put in here a negative sine squared over my still denominator sine squared. Okay, so I'm replacing cosine squared minus 1 with negative sine squared. And then once again, anything divided by itself is just 1, but then I still have that negative out front, so this one reduces all the way down to negative 1. That sounds much better and is more satisfying.